Hi, my name's Charlie Needham. I'm on the Master of Science in Applied Computing.
I'm Sukrathanda, and I'm also in the Masters of Science and Applied Computing program.
I'm Jenna. I'm doing my Master's in Industrial Engineering. And so the motivation for this app, gait variability, the stride-to-stride fluctuations in the way someone walks. You can also think of it as the average deviation from the mean stride time, has been demonstrated as a possible predictive marker for cognitive impairments and falls risks. However, there's a lot of mixed information in the literature. The relationship hasn't been well characterized. And one of the ways that we could address this issue is collect more longitudinal data. So collect more information from patients over time, over the course of rehabilitation. However, with current systems like mats and motion capture systems, this is quite cumbersome and not very easy for the average clinic to take on. So the reason we wanted to develop this particular app was to be able to measure this metric, gait variability, of patients who are undergoing rehabilitation. And the secondary goal, we developed this app in partnership with some clinicians and physiotherapists at Bridgepoint Active Healthcare. And so what we wanted to do is also be able to provide the clinician and the patients some sort of meaningful feedback about this data.
So just going over the overall architecture of our application, we have two major components, the front end, which is the Android application, and the back end, which is the database server. For the front end, we have two sets of users, the patient and the clinician. The clinician is allowed to manage multiple different patients, and the patient is allowed to start measurement sessions. Measurement sessions collect accelerometer data, and we have a data analysis module that processes the data and extracts out important features. Once the important features are extracted, we store it into a local database, and we present the data to the patient in a visualization module. Once the data has been stored, we propagate all that data to the backend server, we are using Baseball, which is an open source framework. And the open source framework essentially stores every trial data as a document, so it can be accessed by different users.
All right, so for our demo, Charlie is a physiotherapist. His patient, Sukrit, has been in rehab for about 3 weeks following a stroke.
For the benefit of this, his name's Beth.
His name is actually Beth, yeah, my mistake. He has an alias. And he already has logged into his app. He can go in and, if this was Beth's first session, he could go into this section and add a new patient. However, for now, he already has Beth's profile already loaded because he's been collecting this data over time. So he has a new session this week with his patient. He can swipe over to the assessments page and add a new assessment. When he goes into the new assessment, he has some options. The first option is to be able to do a timed assessment. The timed assessment essentially allows him to turn the measurement function on and off automatically rather than having to manipulate the buttons sort of while it's already fixed onto the patient. And it also gives the patient both audio and tactile feedback so that the patient knows when the session is starting and stopping. The other thing we've been experimenting with is a metronome function. So this gives audio feedback to the patient as they're walking, as this has been shown in the literature to help the patient gain some rhythmicity back into their gait. So you're not going to be able to hear the audio feedback, but you can kind of imagine it.
Might be.
5 seconds to start walking or prepare myself.
I don't know.
Okay, now my trial is over.
And so now, after the session, Charlie and his patient can go over the feedback of the session, of the feedback that the app is showing them together. They can go into that individual session, look at the data. So here you can see the smooth accelerometer signal. A lot of work went into making sure that the signal from the accelerometer is giving us data that actually accurately assesses each step so that a good calculation can be made. we're also getting some information about the trial, and what we can also show you, a lot of work went into identifying pauses. So one of the benefits of having a sort of mobile application to collect gait data is you can collect data, from a long hallway. You can go out into the environment and not be constrained to a laboratory setting. However, this also comes with its challenges. People turn, they stop, they start, and so work went into making sure that if the patient paused, that doesn't make the metric inaccurate because you're taking sort of this long sort of time between each stride. So what you see there is a pause, and so it takes it into account when it's making the calculation. Charlie and his patient can also go through some of their historical data, so they can sit down and look at what the last couple of sessions has looked like. Is he improving over time, or is his gait variability actually getting worse? We had to make some sort of imaginative metrics for this. There isn't a clearly defined number in the literature for what is an appropriate level of gait variability, but that was also part of the motivation of the app, is to be able to collect this data so that we have an idea of what is quote-unquote healthy or what might be indicative of some problem. So what you can see here is some sort of colors that gives the patient some feedback on how they're doing, and some graphs that can show the patient and their caregiver how things have changed over time. Yeah, that's it. You can also delete sort of sessions if there's a problem with one of them, but that kind of shows the main functionality of the application.
Just deleted. Okay, so to talk about some of the key learnings, there were quite a few things I felt we did really well. So communication, to start with, we were sending emails, but that wasn't really the best way to do things. So we used Slack, which is a useful messaging tool, and it helped us to plan our meetings. So we scheduled a weekly meeting on Thursday. Okay. Also, the collaboration was pretty good between us. Things we could have done better. We mentioned we used Basebox as our server storage. We perhaps could have looked into some other options. And then to move on to future work. So we'd like to do some more analysis, build on some of the data processing, and do some more user testing as well. And that's it.
Great. A great chunk of work. It looks like it really does a data collection system. Are you actually going to use this data?
Yeah. This is going right into my thesis, so
That's
I'm
great.
excited.
Just before, the data analysis is a big deal in this. How do you know you got it right?
The validation study. So they have a really great, expensive motion capture system in the DGP lab at U of T, and so they've kindly allowed me to use their system, and so we're going to do a little bit of validation to make sure
So you
that.
will do, you haven't done that. I see.
Yeah.
Yes,
In
so-
terms of like the average stride time, like we're young, healthy adults, and it goes in the literature of like where like the timing and the variability that we're sort of supposed to be in, but we have to actually sit down and look at whether it's calculating it at the right time.
That's what I was going to ask, if you'd actually tested it against the
Yeah.
machine in the lab yet.
To
Let us know how that goes.
Yeah.
Yeah.
we will.
Any questions, comments? Quiet audience today. Anybody in this field?
Just a question about number 4. Why are you trying to measure problems?
Yeah, so as I said at the beginning, gait variability is a relatively new biometric that people have been saying in the literature might be indicative of a loss of motor control. So as you age, or if you have some sort of illness or disease, they've shown that a loss of control increases your gait variability, and it might be linked to some of these cognitive tests. So the Stroop task, so Andrea is in my lab, and for their project, they've incorporated a Stroop task, which is, that game where you have to say, like, this is blue, but it says the word green in blue. So that's like a relatively standard like psychological test, and so what would be awesome is if you wanted to characterize the relationship between cognitive dysfunction and gait, to have that sort of in one place. So we've talked about potentially doing some combining of these apps after the course is done.